And the last question of this pack, the question is about organic compounds containing nitrogen. Sodium cyanide can be reacted with many organic compounds to increase the length of the carbon chain. So even telling you that. Compound G is used to synthesize compounds H and I, as shown in the flowchart. Complete the flowchart showing the structure of compound G and the formulae of the reagents for reaction 2. Now please note, formulae is in bold, so don't write names, you must give formulae or you won't be credited with the marks. So, if we look here, compound G then, reacting with NaCN and hydrogen ions, produces this hydroxynitrile here. So, compound G has got to have been an aldehyde or a ketone with one carbon. Well, you can't really have a ketone with one carbon, so it's going to be an aldehyde and it's going to be methanal, because the product here has got two carbons. And remember, reacting to form a nitrile increases the carbon chain by one carbon. So we've got to have this molecule here having one carbon. So this is going to be methanal. Okay, so methanal produces the hydroxynitrile here. Reaction 2, we're going to go downwards. The hydroxynitrile then is going to react to produce an amine here. So we're now changing this CN to an NH2. You can see the carbon is there now. So to react hydroxynitrile to turn it into an amine, I would need to react that with hydrogen and nickel. Okay, so again, just straight off your synthesis routes, hydrogen and nickel. And here we have the final part of the last question. So we're looking to take our hydroxynitrile and convert it into a carboxylic acid. Okay, so to do this, we've looked at this reaction before. It was on a previous question. To turn this into carboxylic acid, it requires dilute acid. Okay, so dilute hydrogen ions, dilute sulfuric acid, dilute hydrochloric acid. Doesn't matter which one you choose, as long as it is a dilute acid. And there we go. That's the final part of that question. That's the end of this pack.